All right, exam 2, problem 1. Disk with a radius of 1 meter spinning with an angular velocity of 5 radians per second. It then accelerates, pardon for the lack of the N, then accelerates with an angular acceleration of 5 radians per second squared for 10 seconds. All right, part A, what is its angular velocity at 10 seconds? So, angular velocity, omega equals alpha t plus omega naught. All right, so we have alpha is 5 radians per second squared. We have t is 10 seconds squared. All right, and we have omega naught, which is 5 radians per second. So the angular velocity at 10 seconds is, okay, equals 5 radians per second times 10 seconds squared plus 5 radians per second, 505 radians per second. Okay, part B. What is the total displacement the wheel has gone through at 10 seconds? All right, so the displacement, theta, equals 1/2 alpha t squared plus omega naught t plus theta naught. Now we can assume theta naught is 0, right? Omega naught we have, that's 5 radians per second. Alpha we have, that's 5 radians per second squared. T we have, that's 10 seconds. So 1/2 of 5 radians per second. Oh, missed the squared, right? Times 10 seconds squared plus 5 radians per second times 10 seconds, right? Plus theta naught, which is 0. Okay, so we got, this is going to be in radians, second squared over second squared cancel out, second over second cancel out. So let's get this, equals 0.5 times 5 times 10 squared plus 5 times 10. And we get 300 radians, right? Okay, so part C, if the wheel were rolling on the ground without spinning, how far would it have gone in meters, right? So the displacement, right, the displacement in meters is theta times the radius, right? Theta times the radius. Circumference of a circle is 2 pi r, right? The displacement you go around in meters is theta times the radius. So we got 300 radians times 1 meter radius, so 300 meters. And that's it for problem 1.